Hello everyone. In our class today, we'll be talking about cyclic quadrilateral. Cyclic quadrilateral. Cyclic, cyclic quadrilateral. Cyclic quadrilateral is actually, or can be said to be, a subset in geometry, or a subset of geometry. Now, from the name cyclic quadrilateral, you can see that two things are being mentioned here, or two plane shapes, which of course are what? Circle and a quadrilateral. A circle and a quadrilateral. Like this, a circle and then a quadrilateral. We all know that a quadrilateral is a four-sided plane shape. Four-sided plane shape. So when you see a shape like this, a quadrilateral inscribed in a circle, such shape like this is called a cyclic quadrilateral. So what is a cyclic quadrilateral? A cyclic quadrilateral is a quadrilateral that is inscribed in a circle, or a quadrilateral that has a circle passing through the four corners. The four corners like this. So when you see a shape like this, it's called what? A cyclic quadrilateral. And in answering question on that cyclic quadrilateral, there are two major theorems that we must understand. Two major theorems. And so in this video, we'll be proving these two theorems because your thorough understanding of them will help us to answer any question under this topic. So what are some of these? What are these theorems? The first one is this. The first one states that when you have a cyclic quad like this, that this angle here, that is sum of these two angles, these two opposite angles, that their sum together is equals to 180 degrees. The same thing also applies that this angle plus this angle, their sum is also what? 180 degrees. That the theory says that the sum of the two opposite sides of a cyclic quadrilateral is equals to 180 degrees. We'll be proving that in this video. So now let's say that this is let's label them now. Let's say this is A, B, C, D. Now to prove that the two opposite sides of the sum of the two opposite sides of a cyclic quadrilateral is equals to 180 degrees, I need to do something here. Now I'm going to produce first. It's kind of like a construction. So let's say this is the center now. Okay, please don't mind my shape. Of course, it's supposed to be the center, so I'm going to have something like this. Good. So this is the center O. Okay. Now let me call that I have another angle here. Let me call this X, and then of course another reflex angle here. Let me call that Y. Now I'm going to prove that angle C plus angle A is equals to 180 degrees. Now to do that, look at this. Looking at angle A, from angle A on its own is equals to 1 over 2 x. And what is the reason? There is another theorem that states that the angle at the circumference is half the angle at the center, or in other words, the angle at the center is twice the angle at the circumference. And if you look at our shape here, you can find out that x is the angle at the center, and then since this A here is the one at the circumference, that means that A is going to be what? Half of x, and that is exactly what you are seeing here. What is the reason? You can write it because it's very important that when you ask a question under this topic or in geometry, it's very important for you to write out your reason that the angle at the center is twice the angle at the circumference. Angle at center is twice angle at the circumference. Now, that is that. Now, again, let's look at angle C now. Look at angle C. Angle C also is also 1 over 2y. 1 over 2y. This reflects here. This angle here is also half of this reflex angle here, this y here. Okay, what is the same reason? The same reason as what? As the angle at the center is twice the angle at the circumference. So if that is the case, now what will I do now? I can easily say that angle A plus angle C is equals to 1 over 2x plus 1 over 2y. Now, half is common, so I can bring that out. So 1 over 2 open bracket x plus y. Yeah. Now let's go back to this. So that means that a plus b equals to 1 over 2 x plus y. That is about x plus y. But looking at x plus y, you agree with me that this angle at a point. And remember that the sum of angle at a point is equals to what? 360 degrees. That means that x plus y is equals to 360 degrees. So recall that x plus y is equals to what? 360 degrees. And what is the reason? What is the reason? Sum of angle at a point is very important. Please, when you are solving this, especially in the exam, it's important you write that out. That the reason for this is what? The sum of angle at a point is equals to what? 360 degrees. Now, what will I do now? I can substitute x plus y. Since the value of x plus y is equals to 360 degrees, I can replace x plus y here to be what? To be 360 degrees. So if I'm doing that, that will now give me 1 times 360 degrees. That means that in place of x and y, x plus y, I'm changing it to what? 360 degrees. Since x plus y is equals to what? 360 degrees. Now, what will I do now? Dividing this now. This is 1. Hey, that gives us 280 degrees. So that is it. We have successfully proved that the sum of the opposite angle of a cyclic quadrilateral is equals to what? 180 degrees. So this is the first theorem that we must prove, that we must understand before we can solve questions very well on that cyclic quadrilateral. Now the second one that we'll not be proving now is this. Now let's take let me clean this side now. Let me clean this. Okay. Now, assuming we have a cyclic again, say like this. Okay. Then we have point extended like this. Now, the second theorem states that the exterior angle, this angle here, that the exterior angle of a cyclic quadrilateral is equals to its opposite interior angle. That means that this angle here, if I call this, let me say this is x, and then this is what? Y. That x is equals to what? Y. That the exterior angle of a cyclic quadrilateral is equals to its interior angle. We can also prove that. How will I do that? Now let's call this angle here now. Let's say this is K. Let's call this angle K. Now, from what we just proved now, the sum of opposite angle of a cyclic quadrilateral is equals to what? 180 degrees. That means that y plus k is equals to what? 180 degrees. And what is the reason? The sum of opposite angle of a cyclic quad is equals to what? 180 degrees. Now, having said that, I can decide, let me call this equation 1 now. Now, let's come back again. Looking at it, this is a straight line. Remember that the sum of angle on a straight line is also equals to what? 180 degrees. That means that x plus k is also 180 degrees. Call this the equation 2. And what is the reason for the second one? What is the reason? Sum of angle on a straight line. The sum of angle on a straight line is equals to what? 180 degrees. It's very important you write that out. Now, looking at equation 1 and equation 2, something stands out. Now, I can decide from this equation 1 that y is equals to 180 minus k. And also look at the second one from equation 2. I can say that x equals to what? 180 minus k. Looking at this now, you can notice that the value of y and the value of x, that they are the same. The value of x and the value of y, they are the same. Therefore, we can conclude that x is equals to what? Y. And that is it. And that is so we have successfully proved that the exterior angle of a cyclic quadrilateral is equals to its opposite interior angle. So that is it. So with the good knowledge of these two theorems, once you understand them very well, I can assure you that there is no question under this topic that you will not be able to answer. So please watch out for more videos under cyclic quadrilaterals. So I'll be applying this theorem in answering questions under it. If you have enjoyed the video, we encourage you to please subscribe to our channel so that when I upload new content like this, you'll be notified of them. Thank you very much.